The quadratic formula, the use and understanding. I'm going to show 4 examples using the quadratic formula, paying particular attention to the discriminant, which is the little piece of the formula inside the radical sign. When you use the quadratic formula, you should start from standard form, which is ax squared plus bx plus c. Identify a, in this case it's 9, b, in this case it's negative 30, and c, which is 25. Take the values and place them inside the quadratic formula. Remember, when you have a negative value and you're placing it inside a formula, to use brackets. So we have b squared minus 4 times a times c all over 2a. Simplify, the double negative becomes positive. And now it's a really good idea to do everything inside the radical sign in one calculation, and that will become 0. And that is all over 18. So x equals 30 plus 0 over 18, which will reduce to 5 over 3, or x equals 30 minus 0 over 18, which becomes 5 over 3. Notice that the discriminant is equal to 0, and that the roots are 2 identical real roots, which means this is a perfect square trinomial. In the second example, you'll notice that b squared minus 4ac is now going to be greater than 0, and in this case, the value of the discriminant will be a perfect square. So plugging our values in, a equals 1, b equals 5, c equals 6, negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Negative 5 plus or minus 5 squared is 25, minus 24 is 1, all over 2. So x equals negative 5 plus 1 over 2, which is negative 4 over 2, which is negative 2. Or x equals negative 5 minus 1 over 2, which is negative 6 over 2, which is negative 3. So those are your 2 roots. In this case, the value of the discriminant is a perfect square, so numbers like 1, 4, 9, or 16. When you see a perfect square inside the discriminant, you'll know that it's actually factorable. So if you take this same equation and factor it, it would be x plus 2, x plus 3, and you will get the same values as you would with the quadratic formula. 2 distinct irrational roots now. So the discriminant value is going to be greater than 0, but it's not going to be a perfect square. So it's not going to be 1, 4, 9, or 16, etc. In this case, we have a equals 1, b equals 1, and c equals negative 50. Remember, what we're doing is we're finding values along the x-axis. Put them into the quadratic formula. -1 plus or minus square root of 1 squared minus 4 times 1 times c, all over 2a. This will be -1 plus or minus 1 squared minus 4 times -50 becomes 1 plus 200, so 201 all over 2. And so now we've got a situation where x equals -1 plus the square root of 201 all over 2, or x equals -1 minus the square root of 201 all over 2. So in this case, you've got exact values. And if you were to square root 201, you could figure out an approximate value to whichever decimal you desire. Last example, we have a discriminant that will be less than 0, which will result in 2 imaginary roots. Identify A, B, and C. Place them in the quadratic formula. So B squared minus 4 times A times C, all over 2A. This will become -4 plus or minus 16 minus 20, which is -4, all over 2. So you can see now that the discriminant is going to equal -4, which is less than 0. So you pull them apart. So x equals -4 plus the square root of -4 all over 2. Or x equals -4 minus the square root of -4 over 2. If you're at the stage in your mathematical career that you understand how to deal with taking the square root of a negative number, you can continue. Otherwise, you can stop here and have 2 imaginary roots, realizing that you can't take the square root of a negative number. At a certain point, you learn about imaginary numbers, and you realize that the square root of -4 is 2i. And so you can continue a little bit further. And now I'm going to tidy up the fraction. And those are my 2 solutions. In either case, they are 2 imaginary roots. Now here are the 4 examples that I just went through, set up in a chart. And we're talking specifically about the discriminant. So when the discriminant is 0, you get a perfect square trinomial. And that is factorable. If the discriminant, now again, we're just talking about the discriminant, the b squared minus 4ac. If it ends up being some sort of perfect square, so 1, 4, 9, 16, etc., it's also factorable. So on this side of my chart, you could have factored. On this side of the chart, you absolutely have to use the quadratic formula. So when the discriminant is positive, you'll still get 2 distinct real roots. But 201 is not a perfect square, so you'll have to approximate if you want to go further. And if the discriminant is negative, you're going to get a value of negative something in the discriminant under the radical sign, in which case you have imaginary roots. So just as a reminder, if it's greater than 0, this is the discriminant, just this little piece here. You have 2 distinct real roots. If it equals 0, 2 identical. Less than 0, no real roots. So the discriminant itself is just the piece inside the radical sign, b squared minus 4ac. And lastly, just a reminder, the secrets of the quadratic formula, what it is you're actually finding. You're finding the roots, so the values along the x-axis. And b over 2a, the first part of it, is your axis of symmetry. The second part tells you how far away the roots are from the axis of symmetry, either plus or minus. Thanks for listening.